Welcome to differentiation course. Differentiation has various applications such as rate measure, maxima, minima, errors approximations, mean value theorems. But the most famous idea behind the differentiation is to find the slope of a graph. Okay, let's derive the differentiation formula and understand the differentiation clearly. If you take a graph y equals f of x, let's say this red line here representing the tangent to that particular graph, and the angle between axis and that line be angle phi. Okay, now if you take the point where the red line meeting the curve, I am representing it as a point P of x comma y. Since the graph is y equals f of x, our p y coordinate will be f of x. P of x comma f of x is our point P. I am taking another point which is very near to the previous point P. I am naming it as a point Q. Since these 2 points are very near to each other, the difference between the coordinates will be delta x, where this delta x is the smallest distance between these 2 points. I am drawing another blue line by connecting these 2 points P and Q. Now we got the 4 points, right? They are P x comma f of x and Q x plus delta x comma f of x plus delta x. Okay, by neglecting this red line for some time, let us try to find the slope for these points. I assume you all know how to find the graph with these 4 points, right? Slope we will find using tan theta, or there is a formula. It is y2 minus y1 upon x2 minus x1. Here the slope we are finding with the blue line. That blue line, the angle for the blue line is psi. So the slope of a blue line will be tan psi. Don't confuse the angle phi and psi. So by using these 4 points, we'll try to find out the slope for this blue line. That is tan psi equals y2 minus y1. That is f of x plus delta x minus f of x upon x2 minus x1. That is x plus delta x minus x. So from this, we will get the slope of the blue line, f of x plus delta x minus f of x upon delta x. For some time, keep this tan psi, that is the slope of a blue line. Keep it aside for some time. But there is a catch. We are finding the slope for the entire graph, and it should be given by the tangent red line according to the derivatives. So in order to find the derivative, let us try to develop the equation using this particular red line. So in order to get the derivative using a red line, we have to take the angle phi. That is, tan phi gives us the slope of the particular graph. Now if you take the exact same curve representing both the red and blue lines, whenever delta x is tending to 0, means we are taking a condition where delta x is becoming 0 but not exactly equals to 0. In this condition, the point P and Q will be merged together, because if delta x is 0, point Q becomes same as point P, right? P coordinate. Finally, we have got the condition. That is, whenever the delta x is near to 0 or becoming 0, the both red line and blue line gets united to give us the derivative of this graph. So here is the mathematical representation of this idea. Tan phi, which is the slope of a red line, is equals to slope of a blue line, which is tan psi, whenever the limit delta x is tending to 0. This is the condition. Whenever the limit delta x is tending to 0, the slope of a red line gets equals to the slope of a blue line. Okay, from the previous derivation, the slope of a blue line, which is tan psi, is equals to f of x plus delta x minus f of x by delta x. Substitute this equation in the tan phi formula. We'll get tan phi equals limit delta x tends to 0 f of x plus delta x minus f of x upon delta x. And this is the slope of this particular graph. It is one of the most famous equations of derivatives and it is known as the first principle of derivatives. Let us try to solve some of the problems on it in the next lecture. That's it for today, guys. Thank you. Meet you in the next lecture.